In this presentation, we are going to consider variable speed control of pumps, advantages and disadvantages of this pump control method. Variable speed control is the most effective and most popular pump control method. But whether it is effective in all cases, when speed control is most effective and when it can cause additional losses, these are questions we are going to answer in this presentation. The variable speed control is the method of the pump characteristics regulation by changing the speed of rotation of a pump. How pump performance changes when the pump speed changes. The characteristics of centrifugal pumps depend on the speed of rotation in accordance with affinity laws. Flow directly depends on the speed. Pump head depends on the speed in the second degree. The shaft power depends on the speed in the third degree. For example, the pump heads flow 1000 cubic meters per hour with head 70 meters and shaft power 238 kilowatts at speed 2900 rpm. If reduced speed in twice, flow will be 500 cubic meters per hour, head will be 17.5 meters, shaft power 29.8 kilowatts. You see the great difference in shaft power. That is why speed control is the most effective method in power reduction. Very often pump users consider speed control as an ideal method for energy saving in pumping system which doesn't have any weaknesses. But in the real life, everything is more sophisticated. Let's look at the graph. What is necessary to know? If we need to develop the pump curve for other speed, we need to take several points on the curve and using the affinity laws calculate parameters at the new speed. For QH curve, the dependence is quadratic. It means that all affinity points lie on parabolas, blue and red points. On this slide, QH curves for different speeds are presented. On this slide, the power curves for different speeds are presented. The power depends on the speed in third degree. If we reduce the speed by half, the shaft power will be reduced by 8 times. Look at the example. We have shaft power 240 kilowatts at a speed 3000 rpm. If we reduce speed by half up to 1500 rpm, the shaft power is reduced to 30 kilowatts. That is why the speed control of a pump is a very effective method of reduction of the pump shaft power. Maybe you have noticed that among affinity laws there is no formula for the pump efficiency. This is a very important question. How does pump efficiency depend on speed? The efficiency depends very little on speed. Very often it cannot be taken into account, but sometimes pump users complain that application of speed control reduces the efficiency of a pump. Why it happens? We will consider further. Now let's compare the speed control of a pump and the throttling of a pump. Let's compare the throttling control and speed control from the point of efficiency. For example, if it's necessary to reduce the flow from Q1 to Q2, it can be done by the valve installed in the discharge pipeline and by the reduction of its pump speed. If we use throttling, we need to add the curve of the valve to the system curve and receive the summarized curve, system plus valve curve. The operating point 1 moves to the operating point 2. The pump will deliver flow Q2 at the head H1, but usual head which is required by the system is H2. The difference of heads H2 minus H1 is the losses of the head at the valve, and the red square is the power losses. The usual power required by the system is in a green color. If speed control is used, the pump speed decreases from the 1450 rpm. The system current intersects the pump curve at the speed 800 rpm in 0.11 at Q2 and H2. we see that the pump operating at speed 800 RPM, but without energy losses. Maybe you have noticed that among affinity laws there is no formula for the pump efficiency. This is a very important question. How does pump efficiency depend on speed? The efficiency depends very little on speed. Very often it cannot be taken into account, but sometimes pump users complain that application of speed control reduces the efficiency of a pump. Why it happens? We will consider further. As we have seen, the speed control looks very attractive, but this is only partially true. The efficiency of the control method of pumps strictly depends on the system curve. Let's consider how the efficiency of speed control depends on the system curve, because very often pump users consider speed control as the universal remedy for energy efficiency improvement. I'd like to remind you once again that pumps do not operate independently. The pump always operates in the pumping system, and both of them defines the operating point. As you remember, all characteristics of pumping systems can be conditionally be divided on systems with mainly static head and mainly friction head. Let's consider the behavior of a pump with speed control in systems with different shares of a static head. Let's consider how the pump with variable speed control operates in a pumping system with only friction head. QH curve for different speeds from 1450 to 980 RPM were developed. Corresponding points lie on the parabola, red one. The system curves with friction losses expressed by the formula. If we draw a system curve in accordance with this formula, we also will receive the parabola. These two curves always coincide, and if the pump was selected so that the operating point lays close to the best efficiency point, for other speeds operating points will lay also close to best efficiency point. So the speed control is the best method of the pump control in systems with mainly friction losses. Now let's consider how the pump with variable speed control operates in the pumping system with mainly static head. If the pump with speed control operates in the system with a static head, let's see what happens with the position of the operating point and then efficiency. For example, if a pump was selected at the best efficiency point at full speed, let's see where will be the operating point when the pump speed started reducing. At lower speeds, operating point moved to the left further and further from the best efficiency point. Pump operates with less and less efficiency. So we can make the main conclusion that variable speed control does not give energy savings in systems with high static head, but on the contrary can increase power consumption. The difference in the application of variable speed control in systems with different shares of a static head is shown on this slide. You can see that efficiency stays the same in the system with friction losses and rapidly reduces in the system with the static head. This is the trick which can play the speed control with pump users. Sometimes pump users ask a question, I have applied the speed control but I didn't receive energy saving. Main conclusions. The variable speed control of a pump is very effective in systems with friction losses. The variable speed control is not effective in systems with high static head. Do not use the affinity laws to define the position of the operating point. In many cases, pump speed control gives users great opportunity of power saving, but it's necessary to keep in mind some conditions which are very often not considered by users. For example, the efficiency of the variable frequency drives is not 100%, and its changes depend on frequency. Electric motors with power more than 90 kilowatts should be adapted to operation with variable frequency drives. It is necessary to ask a motor manufacturer. Make your pumping system efficient. If you need more information, please visit our website pumpsaudit.com. See you. Good luck.